I think it's better if we start with, or if we can start in 5 minutes.
Okay, sure. Kang Gustaf yang akan bantu ini, sesi ini ya?
Ya, ya.
Ya, makasih.
Hi, Gustav.
Halo, Chris.
Hi, Gustav. Can you hear me?
Yeah. We can do clearly.
Righty, can you hear me?
Yes, I can hear you, Chris. I can hear Gustav as well.
Hello?
Hello? Yeah, I can hear you.
Oh, sorry. Yeah. You can hear me, Gustav, right?
Yeah. We can hear
Yeah,
you.
sorry, it was my end. Sorry about the issues with the moderator. I'm not sure what's happened, but it seems like our colleague from Telcom cannot attend. So are you okay to facilitate this, to just introduce this session and look at the Q&A? I think it's better if it's a Bahasa speaker.
Yeah.
Okay, thank you very much. Shall we start then? I think because we've got Martha here, so.
As you prefer. I can start now if you want. That would be fine for me.
Yeah, I think we need to sort of open the webinar up so that we can see how many people are listening. Because at the moment, we can't tell.
We have some friends who taking part in this session offline.
Is there any offline participants, Kang Gustaf?
We'll wait for some friends from Relawan TIK who are say that they interested to take part, but
People can submit questions though through the offline one, right?
Yeah.
I think maybe we should just begin. I'm just thinking because of the time. So we can still get Q&As through the YouTube stream.
Sorry, your voice is got.
Can you hear me now?
Can you repeat?
Shall we begin now, because we can get Q&As through the stream.
Okay. So thank you. As you notice, we're going to have a discussion on preliminary research on 6 GHz technology in Indonesia. Actually, there are different session happening currently in common room, and we have some offline participants as well. So perhaps for the discussions we have Marta Suarez from the the Dynamic Spectrum Alliance. Maybe for the Marta can introduce further and then start the presentation, and after that we can have our discussions. So Marta, I give you the time to have the presentation. Thank you.
Thank you very much, Gustav. And hi, everyone. Good morning. I'm literally at the other side of the world. So here is good evening. And I'm very glad and very honored to be with all of you today, because I would like to share with you some discussions and some trends on opportunities on how to provide better connectivity through efficient use of the spectrum. So I will share my screen because I have prepared a presentation. You should be able to see it now. And I'm going to change here. So I hope you can see it. And the title is A New Spectrum Mindset, because for many of you, probably you are not so familiar with spectrum, but this is a public resource that is very important for connectivity. You can imagine a spectrum like an invisible highway, and all the wireless communications go through that highway. And depending on how we manage the access, we could have a very efficient transportation system, or we could have some bottlenecks and then not effective connectivity. So my name is Marta Suarez. My background is engineer. And before working with the Dynamic Spectrum Alliance, I was the General Director of the National Spectrum Agency of Colombia. So a few words about the DSA. We are a global organization. We are non-for-profit, but we represent different institutions, companies, and also non-for-profits. And we advocate for efficient use of the spectrum because we are convinced that that is very important for connectivity, for affordable connectivity, and for innovation. So our mission is to make spectrum abundant for broadband. And for our members, that is important. Among our members, there are the 5 biggest tech companies in the world, like Amazon, Google, Facebook, Apple, and Microsoft. And they are interested on providing abundant broadband because that will stimulate wireless innovation for next generation broadband. We also work with governments, and this is important because there are many policy objectives that need digital inclusion and that accelerate the inclusive digital economy. And mainly, this is important, our mission is to provide solutions for society because there are still many people that don't have access to the internet, and that gap is growing continuously. So it's important to take actions. We cannot keep doing the same things we have been doing in the past because then we are going to get the same outcome. So in terms of spectrum management, it's important to consider new frameworks, new solutions to try to close that digital divide. So let's start with some considerations about spectrum sharing. When we think about the future of wireless networks, I'm sure you have heard about everyone will be connected everywhere, not only people, but also devices, and there will be new generations of cellular. We talk about 5G, now we are talking about 6G. There is also an evolution in Wi-Fi, more satellite networks, and we are having enhanced reality, connected cars. And so this is a massive environment. But then one of the questions we get is like, okay, how should be the next generation? And of course, technology can provide this and much more, but the next generation should try to make sure that everyone is connected. That is the main challenge, to get that involvement, to get that connectivity, and also to find affordable and sustainable models for that connectivity. So So how is it usually structured? So there are ICT, information and communication policies. Depending on the country, you have different ministries that take care about telecoms and ICT. And there are many public policies that recognize this need. So it's important to get digital transformation. And the first step for digital transformation is digital inclusion. Then we also see many policies about connecting the unconnected. There are many, again, as I was mentioning, new technologies, cloud, fourth industrial revolution, data, artificial intelligence, Internet of Things, blockchain, all that. And also stimulate competitions because then there will be better solutions for the final users. How is the spectrum related to this? This is something that for many of you probably say like, well, I don't really see why we should care about spectrum management. And the reason, and we should care about spectrum management because that is the first resource that is needed for any wireless communication. If spectrum is managed and given only to a few stakeholders, then depending on the conditions also how that is granted, because there are licenses that are granted to stakeholders, you can restrict the ecosystem or you can attract investment and create a large ecosystem. And here I took an image like for regulators, it's a very hard job because they have many requests. They have many industry parties requesting everyone what they think is the most important, what they need, and then regulators should try to find that right balance. Somehow it's like they put the music and then everyone will dance with that music. So, so depending on how they allocate spectrum, depending on how they give permissions to use the spectrum, they can create the right conditions for investment and for new technologies to be implemented. And in that direction, we could have a real digital inclusion. So there is it's not a direct relationship, but it's a very important relationship. So, and it's also important to consider spectrum is organized at the international level because the waves, they don't stop at the boundaries. So that's why we have signals that can go, for example, those old radio signals that I'm sure your grandparents used to connect to those signals, and you could hear the radio in Moscow or in Brazil or somewhere very far, because the waves, they don't stop at the boundaries. So you need international coordination on how to use frequencies. However, it's important the local context because depending on, again, on the rules, you can create a local market, you can promote more infrastructure deployments, and then you can also create perspectives that are based on the real priorities of the country. So first, it's important to recognize also that different technologies are complementary, that it's not about saying, okay, let's focus all our attention on satellite. And then you see that you don't have enough terrestrial networks and that people, most of them connect using a computer, a tablet, or a phone. And then if they don't have those terminals, you won't have enough coverage. So it's important to get the conditions for all the technologies, satellite, mobile, fixed, unlicensed, licensed, etc. And in many cases, it's possible to have coexistence and to have them operating. Instead of trying to clean a band for every technology, you could have a spectrum sharing. And that is a very good alternative to release spectrum for broadband. And because spectrum is a limited resource, many frequency bands are already occupied. And then instead of cleaning that, because that is very expensive and takes time, you could use spectrum sharing to get more connectivity. So let me try to explain it with a picture of the real estate. So if you're living in a big city, you can buy a house, and then your house could be in a very residential zone, but there are also sectors for offices. And so you can imagine somehow, it's not exactly that, but just for the exercise, spectrum licenses are that type. You get a license, so it means that you own your place in the city, so you can use those frequencies for the purpose that you got them for, so any purpose. But in a big city, it's always hard to find new places for more constructions. And you don't only have, I mean, you have licensed places, but you also have open places like parks. No one owns the park, that is a public space. So it's important to have a good mix of licensed and unlicensed. So in this case, properties and public spaces. And it's always hard to find new spaces for public access. So you have these pictures here that show that in many cases, in the middle of the city, you can have a park on the top of a big building, and then you can mix and have some type of users in the low part, and then public access on the top of that. That's kind of the concept of spectrum sharing. If you have a particular frequency band that already has some services operating in the band, you could also have a spectrum sharing, and then you could have new services in the same band. Of course, that needs some coordination, but it's a very efficient use. And then it's very important because with these solutions, you could have more coverage and more opportunities for those that don't access the spectrum. For example, a great example are the community networks. So you could have places where no one is using the spectrum, and then you would, even if someone has a permission, or even if they have a region that is not covered, you could have used that slot of a spectrum for a community network. Or the same example, we're going to see it later, could happen with Wi-Fi. There is a particular band, the 6 gigahertz band, that is already used by satellite, by fixed links, and by mobile allocations. And then on the top of that, you could also have Wi-Fi. So it's a very efficient use of the spectrum. As DSA, we promote these type of concepts using technological means. So there is an important role for new technologies to coordinate access to the spectrum. And we support the use of those technologies if they're going to make it more efficient. But the purpose is not the use of the technologies, but the final goal is to provide more broadband access. And why is spectrum sharing so important today? Because we need to make networks more affordable. So sometimes, instead of just relying on private networks, we could have solutions that are, if you have easier conditions to access the spectrum, then you won't charge the final users for that price of the spectrum. So at the end, the networks are more affordable. It's also important to support rural broadband. And this is all around the world. Even the most developed countries are trying to find solutions to close that gap between cities and rural areas. And then spectrum sharing could be extremely useful because it's about using those frequencies where there are large ecosystems of equipment that are not really being used right now, and give the opportunity for ISPs, for communities to use that spectrum and to deploy their networks. It's important also to support innovation, because this is something new, creating the systems that will manage access to the spectrum. The new generations of devices that are coming and that are deployed for dynamic spectrum access are all of them innovative. So yeah, we are going to the boundary of creating new applications, and this is, it depends. You could have very innovative solutions for rural connectivity, but also we could have innovative solutions for new technologies, like, for example, augmented and virtual reality. So using dynamic spectrum access, we can facilitate deployment of, for example, very low power devices that we could use for the glasses in augmented reality or virtual reality environments. It's also about changing the spectrum crunch conversation. We are used, for those that have been working on spectrum management, we are used to hear that spectrum is a scarce resource. It is a limited resource, for sure, but depending on the management, we can make it abundant. And so somehow that's the new mindset that we are promoting. It's enabling 5G because also there are frequency bands that are used by incumbents, and going through a clearance process is complicated. So in some cases, spectrum sharing can also accelerate the adoption of 5G. It is connecting wireless devices and the IoT. This is important for many applications. For example, now in agriculture, there are many IoT devices that could be extremely useful for those that work on the land. So if they get the information about the land, about the humidity, about the type of the soil, they can make more informed decisions and they can be more productive. So creating also opportunities for IoTs is very relevant. And in those cases, you need solutions so that devices won't be too expensive. Because if IoT devices are too expensive, then they are not going to be used because the price will be too high. And in that context also, unlicensed access or spectrum that you don't need to pay for a license for that spectrum creates opportunities for lower cost and sustainable models. And also spectrum sharing is important for new technologies like Wi-Fi. Currently, this is a figure for Asia Pacific, not only for Indonesia, but for all the region. And here we can see the traffic, the internet traffic in general. This is taken from Cisco. And you can see by 2022, the last column, you will see how people access internet on what type of devices. So about 14, no, there is a mistake there. Yeah, there's a mistake there. It should be about 29%, no, or less, 19% is through mobile. Sorry for the mistake. 20% is through Wi-Fi only devices. 50, there is a mistake for all those numbers. Let's take just the relation. Sorry for the confusion with the numbers. The green ones are those that are accessing internet through Wi-Fi in their smartphone using a mobile device. And the dark blue are those that are accessing internet through a Wi-Fi only device. Just by the graphics, you see there that more than half of the traffic is going through a Wi-Fi network. It could be a fixed or mobile device, but they access internet using a mobile, a Wi-Fi connection. And because of that request from the users, it's important to dedicate new solutions and new spectrum for Wi-Fi. Here you can see the evolution from Wi-Fi in the 2.4 gigahertz band, then we had the 5 gigahertz band, and then we have been increasing the technologies of Wi-Fi. So currently, the most recent technology for Wi-Fi is Wi-Fi 6, that's the name. And if we can use the 6 gigahertz band, it will be really a lot of capacity and also capacity to handle many users and low latency. So what Wi-Fi 6E, so it's Wi-Fi 6 in the 6 gigahertz band, provides very low power applications, low power indoor applications, and standard power. I think all those three are important for final users, but in particular, I think low power indoor and standard power might be very important to connect those that are still unconnected. Standard power applications can be outdoor, and they could be used by ISPs to provide that last mile connectivity. Many of them right now rely on Wi-Fi equipment in the 5 gigahertz band. And they complain because there are many users at the same time and they cannot provide enough capacity, and you have most of the channels used. If we have additional spectrum in the 6 gigahertz band, then ISPs will be able to provide better connectivity and more capacity to their customers. And there is a global momentum on the future of the 6 gigahertz band. Right now, there are 8 countries in the Americas that have decided to open the 6 gigahertz band. Europe has an European decision for opening for additional spectrum in the 6 gigahertz band, not 1200 megahertz, but 500 megahertz. And in the Asia Pacific region, we are having different consultations about the future of the band. What we have now is more than 40 countries that decided to dedicate additional spectrum in the 6 gigahertz band for Wi-Fi. If you remember the picture of the buildings, in that band, we already have fixed service, fixed satellite service, mobile, and additionally, we would have Wi-Fi or unlicensed access. It could be also used by other technologies. So that is what I would like to present. I would be happy to answer more questions on that. And now let me very quickly refer also to another technology that could be very useful for connectivity in rural areas. This is a technology, the name is TV white spaces. And this is a technology that is growing worldwide. It is not focused for the main cities, for the big cities, because in those cases you have other broadband solutions that might be already available. TV white spaces is ideal for those environments where you don't have enough coverage with the traditional technologies. As its name says, TV white spaces operate in some frequency bands that are named UHF, and these frequency bands have the main advantage that they have large coverage. Those are the same frequency bands that are allocated to broadcast, to TV. So they have large coverage, I mean, because of the propagation of the waves. And so that is their advantage. They can use the spectrum that no one else is using it. So you could have some channels for TV, but when you're changing your TV, you will see that sometimes you have no channel there. That is a white space because it means that no one is using that channel. And then you can use that channel for broadband. And that is using the TV white spaces technology. And this is a very good opportunity to address the connectivity gap and to bridge the digital divide. I will close, this is my final slide, saying that for this it's important to have strategic collaborations for digital inclusion and flexible frameworks. So at the DSA, we work with different stakeholders, and as part of the collaboration that we are having with the digital access program of the FCDO, we are creating those cooperations and those collaborations. We work with local partners, with the Telecom University, and also with access partnerships. So we would be very glad to work with you and to provide additional information if you are interested on this subject. Thank you very much.
Okay, thank you, Marta. It was a really interesting presentation, and actually we have some questions from participants here, from Fajar Eridianto, head of Relawan TIK or National TV in Indonesia. Said that how is it the 6 gigahertz spectrum can be implemented in Indonesia, because it seems it is very feasible to implement, especially for the digital literacy. And he also want to know more about he wants to know more about the security and how the local community can be prepared to use this technology.
Thank you. So at this point, Indonesia doesn't have any regulations for the 6 gigahertz band. So as DSA, we are in the process of exploring the possibility of unlicensed access in that band in the country. We have been working with regulators all around the world, and we are seeing that good momentum that I was presenting before. We have done an economic study, and we have found that there is a very important benefit for the economy in Indonesia if that ban is open. Because even if it is for unlicensed access, there are no, we don't have an auction. So no one is going to pay for the spectrum because it would be unlicensed. However, that will have a huge impact on the GDP of the country, because if more people have access to broadband, then you have a percentage of the GDP that will increase. And there is also benefit for communities, for consumers, and for Indonesian companies. Especially in the case of the standard power applications, it will be important for internet service providers. So I think the first step is to get approval from the authorities, from the ministry, from Coninfo, to understand and to see the benefit. And then if they decide to open the band, the equipment is available because there are many countries that already have the regulations, and then it would be relatively easy and fast that companies or consumers could transition and have new equipment, and then they will be able to use the technology. So that is where we are. In terms of the security, Wi-Fi 6 and Wi-Fi 6E, so the new generation in the 6 gigahertz band, implements a new standard for security that is named WPA3. So previous Wi-Fi's had WPA2, and this is an evolution in terms of the security. However, it is important to recognize that the security is not really at the device level itself. It depends on the applications and the use that the user is giving to their devices. I mean, you could be hacked using your mobile network, or you could be hacked using your Wi-Fi connection. It depends on the security and how you handle the information and in your terminal. So, I mean, there is a very good part on that. So, that's where we are again.
Okay, thank you. We have one question from offline participants here. He said that as you probably noticed, in Indonesia we still have a huge gap on digital divide. One of the challenges is a lot of people in Indonesia doesn't have proper devices to access internet. So in terms of implementation of 6 gigahertz technology, there are raising concern how the end user can use this technology, and is it going to need a specific device for this, or we can use already available device in the market?
That's a good question. So the 6 gigahertz band is not being used by Wi-Fi. So all the new equipment that will be developed and that will function operating the 6 gigahertz band, if you have the two terminals working in the same band, you have the best performance because you are going to use all the spectrum that is available with the new generation. However, if you have previous generations of Wi-Fi, all the routers, and that is what we have seen in the Wi-Fi industry since the beginning, they can use the previous generations of devices. What is going to happen is that if you have all the devices, you might connect to a Wi-Fi 6 router, but you won't have the best performance because you are limited by the type of terminal you have. We have seen that the transition of equipment takes a few years. So we expect that once the regulations will be in place, there will be a natural transition and adoption of new devices, including Wi-Fi 6E. Right now, the new generations of smartphones come in the countries where the regulations are in place, are already Wi-Fi 6 or Wi-Fi 6E certified. So that will take a time, but you need to compare that with other technologies that provide similar capabilities. It will be much more expensive, for example, to have a 5G mobile phone that will give you also throughputs of about 1 gigabit per second. You could have similar throughputs with Wi-Fi 6E and with 5G, but the cost of the chipsets of Wi-Fi are about an order of 10 of magnitude lower than the cost of 5G chipsets, because Wi-Fi is massive. So you have economies of scale that are global. So it depends what you are comparing it with, but we think it will be more affordable in terms of devices, and you will have it in much more devices. You will have Wi-Fi 6 in computers, tablets, smartphones. Even now, the TVs that are connected to the internet, they have chipsets, Wi-Fi chipsets, and that will be very hard to have with other technologies, especially for licensed access spectrum.
So thank you for the answer. We also have this question that how about the study of 6 gigahertz technology implementation in Indonesia for the readiness of Indonesian user and ecosystem in Indonesia?
Could you please repeat? It broke a little bit.
Yeah, there's a question about is there any already study on the readiness of Indonesian market and ecosystem for the 6 gigahertz technology?
We haven't, it's not really entirely a market study, it's an economic assessment. So what we have done for Indonesia is we assess the economic value of the economic impact of unlicensed access to the 6 gigahertz band. And we were identifying different sources of value. So, for example, we identified how that will impact the situation in the country of having more hotspots that could use Wi-Fi 6 and Wi-Fi 6E. And then we took into account the number of people that access internet through a public hotspot. It could be because they cannot afford a fixed internet connection at home, so they rely on public services. And then for that source of value, we estimated the economic impact. Then another example of a source of value was, for example, the internet that is provided by ISPs. So we took into account that market in Indonesia, the number of users of those ISPs, and then we also made some projections on how that would increase the connectivity for the final users and how that would help those providers and how that will have an economic impact on the revenues. And another, for example, there were like 10 sources of value, but for example, another one that I think is very important would be the impact on augmented and virtual reality market in Indonesia. And that is very relevant also because there are many applications that you will need content in Japanese, you will need content for training, for education, even for entertainment, and that will be prepared by local companies. So that will have a huge impact in the market. If the band is made available in the short term, then it will be possible to start that market immediately. You won't need to wait for a mobile connection of those devices. You can use them at fixed locations using Wi-Fi 6E, and that also we quantified the impact on the national economy. So the study is not public yet, That has been done under the cooperation that we have with the Digital Access Program. We have presented the preliminary results to the authorities. We're in that process, and once that will be completed, then we will make it public. But we have found very relevant numbers and a huge impact on the national economy.
Okay, thank you, Marta. We have another question. Okay. Yeah. So the 6 gigahertz technology is interesting. Is there any chance to do a tryout or experimentation to implement this technology in Indonesia on local level?
We haven't really had a lot of trials because we had the experience, if I may say, with TV white spaces, that at some point it was trials and trials and trials. And if you don't have the regulations in place, then it is like, I mean, you need the regulations then to make sure that you can make investment. The technology works. We have had demos. I would be very happy for those that are interested on trials to have bilateral meetings. I can show you the demos, how the equipment behaves. We have had trials or demos mainly where we were measuring 2 gigabits per second between a router and a mobile phone that had Wi-Fi 6E. So this is really very high throughput, very low latency, and it looks very similar to what we have now on a Wi-Fi router. And that type of test we have done, like connecting a router, a mobile phone, or a computer, and measuring the latency and the throughput. But for the regulator and for the authorities, they are usually more concerned about coexistence tests. And then you cannot measure that because you need to simulate what's going to happen when you have thousands of devices connected at the same time. And then we have done also studies to prove that it's possible to have the coexistence. And that's why more than 40 countries already have decided to create regulations and to open the band. So our expectation is better to have regulations in place, and then for users and for companies that want to access to Wi-Fi 6E, then they can invest directly and they can start using the technology. But if anyone wants to see that, please let me know. I will write my email here, and or please through Gustav, and I will be really happy to show you how it works.
Okay, so Marta, this one is actually from my side. Is there already a communication going on with the national authority in terms of policy for the 6 gigahertz regulation?
Yes, I mean we are starting the process in Indonesia. The process itself is like we made an economic study. We are presenting the impact to the authorities, and then we expect hopefully to. Of course, there are many questions, and that's more than normal. we find those questions everywhere, and it makes sense. So we have those conversations, and then hopefully there will be a public consultation. So it's very important for all the participants here today to know that this is under consideration and the benefits that could be obtained from unlicensed use of the spectrum and Wi-Fi 6E. So you would be more informed, and then hopefully you might be able to participate in the consultation in the future. I don't know if I answered your question, Gustavo, or if you need anything else.
Yeah, well, I just want to know how, as civil society organizations and community can be involved in these discussions to disseminate further understanding on 6 gigahertz technology implementation experimentation?
I think for the communities, they will be, there could be two sides. They could, of course, benefit of the technology, but also if they are having initiatives like, for example, community networks, or if you have ISPs in the participants, that's important for them. We have found in other countries that they need additional spectrum. They are desperately needing more capacity. And then Wi-Fi is a very good solution for that last mile connectivity. It combines very well with satellite or with microwave links, or even to download, to offload mobile traffic from the mobile network. So I think that at this point, the main challenge is to get the regulations. And once that is achieved and that is accomplished, there will be so many use cases and so many interesting projects that could be developed.
Thank you. So I think there are no further questions from participants, but I think, yeah, I think what is already mentioned by Ta is, I think it is a discussion among civil society organizations and community here in Indonesia.
Definitely, and we are, as I
can have more information, especially how we can the implementation of 6 technology in Indonesia, and if there any chance to do some experimentation or try out or something like that, we would be interested to part on that.
Perfect. And
yeah,
for us, it's very
actually
important
in Indonesia, we have Ministry of Communication regulations that allow to do such experimentation as long as it's not for commercial purpose.
Yeah, for us, it's very important to have the opportunity to present it to you and to the civil society in general. And yeah, I think we can keep in touch. One of our partners, as I mentioned before, is Telkom University. So I think through them, we are also planning to have some roundtables, and it would be very important to get a better understanding of the local context. So you have that experience on the field. You are the ones that are really seeing the last mile connectivity, the last link to the final users. So we would be really glad to keep this conversation and to see how we could work together on getting this done.
Okay, let me check if there are any. So, okay, so there are no further question on this. But for the wrap up our discussions, if you have any final statement or reflections, you may do so.
No, my final comment is like, the technology could provide many solutions. We need to find together affordable and sustainable frameworks. And probably some of you are not so involved on spectrum management, and it's good to have this opportunity to merge the two worlds, the experience you have on field and the experience that we have on spectrum management, so we can try to get a good solution, not only for one technology. I mean, it doesn't have to be only Wi-Fi, it could be also TV white spaces, it could be some types of spectrum sharing for communities. You know, there are so many options. So my final message is like, please count on us. We are here. We would like to make it work, and we are engaged to see more people connected in a sustainable and secure way. So it's really, really exciting to have this opportunity.
Okay, Marta, thank you for your time, and looking forward to have more discussion and collaboration with you. Have a nice weekend, and it's good afternoon. Yeah, is already evening, yeah, in your country.
It is 9:45 p.m. It's Friday. It's still Friday here.
Okay, okay. So good to discuss with you, and hopefully this our encounters can also stimulate ideas and inspirations among different communities here in Indonesia, and looking forward to have more another discussions with you.
Thank you very much. Have a good
Okay.
day. Bye-bye. Bye.
Bye. Thank you.